So anytime you want to think about the neurobiology of learning and memory, you really have to realize, you have to deal with this two very separate traditions. So there is the cognitive neuroscience tradition, cogneuro. And that is, we're going to look at how it is people learn, and we're going to do this by examining folks who've suffered brain damage, or examining folks as they go about learning something but are in a magnetic resonance imaging scanner. Right? So that's one approach, the sort of whole organism approach. In this case, you can study learning and memory in a rodent, that's him, in something called a T-maze, or any other kind of maze. We're going to find another kind of maze that's really useful. It's called the Morris water maze, named after Morris. Yes, sirree. He's still active, or at least he was the last time I checked. Morris water maze. And this is, can an animal learn which direction to turn? In this case, he's given a choice. Can he learn so we can put food over here? And does he learn that the food is over there? And you can study an animal and figure out what parts of the brain are important for that. So that's one approach. Now the other approach is a much more cellular and molecular approach. And that is, what is it that has to go on at the level of single neurons or at the level of synapses in order for an animal to learn something or to remember something? And we're going to look at both of those approaches in this lecture. So let me start off by telling you that there is no such thing as memory. There are many types of memories. So the types that I'm going to spend most of my time talking about we call declarative. Some other folks refer to these as explicit. And these could be memories of facts, times, places, locations. All right, so you can do that. You can go and tell your family members that there's a new video up about memory, and you're learning these two sort of approaches, one cognitive, the other cellular molecular. That's a fact, and you're going to be able to talk about that. You'll even be able to tell people where it is, where you were on your computer when you heard this. Right? So those are declarative memories, and that's fine. Then there are others, we call them implicit, often referred to as procedural. Motor memories are procedural. You can practice something and get better at it, but you can't talk to someone through it. You can't substitute the spoken word for that practice. It is implicit in what you do. Or you can be frightened by a particular kind of music. You know, you may not know the first thing about music. I don't know the first thing about music, but when I hear a particular kind of music, it gets me frightened. So that is also an implicit or procedural memory. Sometimes, well, some of these can be referred to as emotional, right? Others of them can be referred to as motor. And it turns out that there are different parts of the brain that are important for each of these things. So emotional memories, your ability to evaluate a situation, recognize it as something that was fearful or joyful before, and thus feel the fear or the joy again. Well, that's all part of a piece of the brain called the amygdala. It's really quite large. It's in the medial temporal lobe. Well, so too is the part of the brain that's important for declarative memories, and that's the hippocampus. And by important, I mean if you were to take out the amygdala bilaterally in a person, he or she would no longer be able to establish new emotional memories. Similarly, as we will see, a bilateral damage to the hippocampus, so damage to the hippocampus in both hemispheres, winds up eliminating a person's ability to form new declarative memories. They may still do remember facts that happened before the damage took place, but they can no longer make new declarative memories. Now, motor memories, I'll just briefly mention. There are memories of skills, and you can acquire new skills pretty quickly. I can give you a new mouse to use on your computer, and the mouse is much more sensitive than the one you're using now. And so you learn very quickly how to make more fine movements in order to move the mouse the way you want to. Or you can shift from a car that has a really tight steering, really excellent brakes, lots of pickup, to a car that has looser steering, soft brakes, not much pickup. And after a couple of blocks, you're able to drive that car. So, okay, you can acquire new skills. I'm going to tell you the cerebellum is absolutely important for the acquisition of new skills. But then there are motor and other sorts of behaviors that we think of as habits. Particular sequence. Games are perfect for this. You think about games that you play, and there's a certain sequence of buttons you have to push in order to get the character, the avatar in that game to move a particular way. You, by habit, learn what those are, but that doesn't happen instantaneously. It takes time. And habits, well, I'm going to tell you the part of the brain that's key to forming new motor habits and other kinds of habits for that, the basal ganglia. All right, so we're not going to talk about much of this, the motor. We are going to spend some time talking about procedural memories, emotional memories, and we'll spend a lot of time, a great deal of time, talking about declarative memories. Now, one last thing in this particular first video in this lecture is where you can see the parts of the brain that are important for the establishment of two sorts of memories, the amygdala and the emotional memories, and the hippocampus and declarative or explicit memories. Right, so they sit one in front of the other. So they're both found in the medial temporal lobe. If you stick your finger just above your ear and you started to drill through the bone there, you would run into the temporal lobe. Okay, great, that's the temporal bone. If you go a little bit in front of your ear and you were to drill through all of that, you would run into the amygdala. So you'd have to tear through all of the cortex of the temporal lobe. You have to get into medial temporal lobe. That's where both of these are found, medial temporal lobe. In the anterior part of the medial temporal lobe, that is closer to the eyes would be sitting right here, is the amygdala. The amygdala means almond, and it is an almond-shaped structure. It has many different nuclei in it. So it's not a single nucleus, it's a complex of nuclei. And I'm going to tell you that it is the key to an establishment of new emotional memories. If it is damaged bilaterally, people display a syndrome which has them unable to evaluate a situation for its emotional content. Animals and mammals and people have a difficult time responding appropriately to the emotional content of a situation. So one of the cardinal features of animals that have had the amygdala removed on both sides, and people, is they are fearless for most things. So things that ought to prompt fear in them, they don't express. One of the funny ones, well, I don't know how funny it is, but a monkey that's had the amygdala removed on both sides no longer is afraid of snakes. Monkeys hate snakes. You think you hate snakes? No, you're a piker compared to a monkey. They hate snakes. But you blow out the amygdala on both sides, and your friendly neighborhood monkey will handle a snake with no difficulty. All right, so That's the amygdala. Then there's the hippocampus. Hippocampus means seahorse. That's just what it means. And it does look like the seahorse. It is a C-shaped structure. Well, actually, the axons that leave it are. So this is the hippocampus here. This thing right here is a bundle of axons that goes from the hippocampus to the hypothalamus, and is called the fornix. So the hippocampus sends axons to the hypothalamus. Hypothalamus would be at the base of the brain down here, and that's the fornix. Those are the axons that go from hippocampus to hypothalamus. No big deal, but the hippocampus is key to taking what is going on in the world right now and then incorporating them in such a way, changing them so that they get deposited, as it turns out, elsewhere as permanent memories. So hippocampus isn't, as I will show you, isn't where memories are stored, but it is a place that's essential for making new declarative memories, for learning new facts, or for learning new locations. Okay, so we're going to spend a lot of time talking about the hippocampus, in particular medial temporal lobe, more generally as places, as the geographic region that's important for the establishment of new declarative memories.